episode of FUM0149 we are going to make the ja vittu se nyt on. Pinion. Hello! In this episode of FUM0149 we are going to make the pinion for this new lathe tailstock. No, the lathe is not new, the tailstock is new. So it's a sort of a complex thing, not the easiest of all, and there are a lot of different operations and mostly in the lathe, but also some milling work. So let's start with the lathe work. Well, now that's about the late job. Well, after parting off, I just made the similar operation on the other side. They are pretty much identical. But now we need to make the actual pinion here. And well, for this reason I'm going to set this up, and this is I have already started. I put my dividing head here. The mill is in horizontal configuration, and now I will just set this up, see that it's straight and dialed in. This is a 4-jaw chuck, so I need to clock it in. So now this is dialed in. So first of all, this is clocked straight, so it is straight in this way and also this way. So well, yeah, that very simple operation with the dial indicator, and that's it. But now we need to the nice thing about module 1 or module, but module 1 especially. Module 1 gears and in the metric system. So well, if you want to make, let's say, a gear with 20 teeth, so what will be the diameter be? Well, it will be 22 millimeters. And this 22 millimeters comes from the fact that when you have 20 teeth, so then there is a so-called pitch diameter, which is an imaginary diameter, which is not on the top of the teeth, not on the root of the teeth, but in between. And now, since from that imaginary pitch diameter, the height of the teeth above that is exactly 1 millimeter in metric gear system. This means that you have to add once for the top side of the gear and the other time from the underside. So 2 millimeters. So therefore, the diameter, the whole diameter of a 20 gear with 20 teeth is 22 millimeters. Okay. Same applies reverse. We have here I decided this to be 25 millimeters in diameter. So what is the number of teeth I would like to cut into that one? Well, of course, I would like to cut 23 teeth. Yeah, well, it's reverse engineering. So I will cut 23 teeth into here, and the depth of cut will be the top of the gear is 1 millimeter, the under of the gear addendum, that's the correct word, and then we have the dedendum, which is actually the underside, under part of the tooth. It's also 1 millimeter, and then we have a clearance in the very root, and that's 0.25 millimeters. So the total cut of depth is 1 plus 1 plus 0.25, which is 2.25 millimeters. You don't need any calculator for that one, and that's nice, really. Okay, Well, the things become a little bit more complicated when you have like module 3, which is everything is 3 times. But module 1, that's good. Okay, so we know what is the depth of cut. Okay, so I centered this cutter, which is, by the way, it must be cutter number 4. Number 4 is from 21, wait a minute. Well, that black book doesn't tell everything. I have a book like this which tells me, because I have written it here, from 21 to 25 teeth. And this 23 is in the middle. Very good. Then we get the best tooth profile for this one, with this number 4 cutter. Okay, so now it's on the center. Now we need to align it so that it will touch this thing. And for that I'm going to use paper again, office paper. This is, of course it's not touching. We need also those. I want to see something. Oh, yeah. Let's see now. There you are. It's already cutting, actually. So let's take one then a little bit back, like that, and then we zero this one. There you are. And yeah, now it's no more cutting. And then I have already checked that I have the clearance here, because sometimes this is again an issue. Okay, now we need to move the table up 2.25 millimeters. So that will be 1. Okay. That will be 2. Okay. 25. 25. There we are. Not that one, that one. Okay. And we still should be. This is pretty near. Oh man. I need to set a stop here somehow, that I know where to back. Okay, I can put this as well, so I know where. Let's put it on the 10. I would really like to have a hard stop in this one, but we don't have that. That would be nice. Okay, I can use that one too now. Then I back up. Let's see if I can do that. Okay. So now the cutter is well aligned. I have set my limit so that I don't crash this. And now the next step is to set up the division. And here we have, I will start in 0. I would like to do that. There you are. Okay. So it is 23 teeth. That's that's a prime number. Means that you cannot optimize that in any way. So you need a disc with 23 holes. That's your only option. And or multiples of 23. You would have also a disc with 46 holes. That would do. But in my case, I have a disc which has 23 holes in it. Since you need to rotate this thing 40 times for a full revolution here, it means that you will be getting 23 times 40 holes altogether. Okay, you don't need to do the multiplication. It's sufficient to know that to advance one teeth you need to go past 40 holes. Yeah. So I have set these sector arms here so that it's a full turn and then to the next hole pointed by the sector arms. Then it is 40 holes. So it's 23 plus 17. Well, we should be good to go. So let's mill that. Now let's advance to the next hole. First of all, there is a break in this one because these things have a lot of backslash. So I release the brake from here on the back side and then I go 40 holes. It means that I will go, now it's 23, and then to the next sector arm. It will be in there. Okay. And then I advance the sector arms, and failing to do this would be disastrous. And then there is a backslash, so I take away the backslash manually and then tighten the brake. Ready for the next hole. And this should be repeated now multiple times. We have already one whole teeth, and we need to do this 21 more times. So bear with me. Well, we have a fully functional pinion here. It meshes, on my opinion, quite well. There is no rattle. It doesn't want to, it meshes well, I can tell. But there is one anomaly in the gear rack. There you can hear it. That should be, I believe I figure out what that is and file it away. I believe that there is just one high spot or burr or something like that. But other than that, this is now really well, really good. Okay, and yeah, in the next episode of FUM0149 machining, we shall be doing one additional feature for that one. It will be, this is, there will be a cam which needs a locking mechanism, and this one I will figure out in the next episode. Till then, bye!